Hello everybody, welcome to another stream. How's it going? Welcome, welcome. Oh, so last stream we were binning ellipsoids into screen tiles. Um, we haven't technically binned them yet, although, wait, hang on a second. Hey there, Destrin, how's it going? Wait a minute. Okay. Oh crap, okay. Go back. Right, I'll be right back. Just gotta sort this boy out. Right, welcome back everyone. Sorry about that. um, yeah, the little one just woke up because he needed tending to, so his should be fine now. But yeah, where was I? So last stream, we was working on binning ellipsoids into screen tiles. So each tile in the screen gets an array of ellipsoids to render. So when we render a pixel, we can look up the array in, or look up the tile that the pixel is in and get a smaller array of ellipsoids to try and render. And we basically just do array verse ellipsoid intersection versus, all those ellipsoids. So, yeah, these are what screen tiles look like. They're like 16 by 16 pixels. For resolutions above 1080p, we probably want to make them a bit bigger, but we'll see. So for now, they're just 16 by 16 pixels. So we haven't actually done the binning itself yet. We've nearly done it though. Technically, they've not been. We've created the bin entries, but they're not actually in an array. So the method we're doing is we've got this compute shader, which goes over every single ellipsoid, gets the screen bounding box for it, and then it yeah, then it goes over all of the tiles in the screen bounding box overlaps, and it will insert an entry into this sort keys and sort payloads array. And in the sort key, it has the tile index in the high bits and the depth as fixed 0.88 in the low bits of the sort key. So then we can sort the whole array, or the two arrays together. The payload just being an additional bit of data alongside that sorted information. And then we'll have an array of ellipsoids that is a different size depending on between the tiles, basically. Cool. So last stream we actually had a bit of a bug, and I guess let's just start there really. So this bug is to do with when we look directly down or directly up this screen bounding box. Bearing in mind, this doesn't represent the ellipsoid we're seeing here. There's a different one from on the CPU which we're visualizing. But yeah, when we look kind of perpendicular to the direction towards the actual ellipsoid, we get this. It stretches, right? So I just got to figure out like what that is, because it even works when you go up as well. We stopped the one when it was behind, because that was sort of like a negative depth. But this is something else. So we'll investigate this one, and then we'll carry on with the actual binning and then trying to render them. So this would end up basically putting that sphere or ellipsoid in every single tile on the screen, effectively. So it seems like the it stretches more and more and more, and then there's something that happens about here. It's not exactly 0, right? But it's nearly 0. Weird. Hey, Perry. I'm doing okay, thank you. Doing quite good. In terms of like what I'm doing every day, but I don't know. Got a bit of a stomach thing going on, so I'm feeling a bit down from that. But other than that, I'm good. Is this engine work? Sorry, how is it? How is engine work? How is it? It's good and fun. But yeah, it's fun. If you have the time for it, I would recommend. You know, if you like building stuff from scratch and having control of your own code base, yeah, I think it's. I'm not sure if that's the question I wanted to ask. But yeah, rephrase it if that didn't answer your question. Um. So, um, let's take a look at some of the maths behind getting the outer ABB on the screen from a local coordinate. So we just, from a local 3D bounding box. So we take the local 3D bounding box, get the outer bounding box for it in E space, right, but then a view from local transform. I think that's okay. It must be to do with the stuff that takes into screen space. So, oh no, it might not be. No, these should be okay. We could print some of these out. Drop a print in somewhere. What are we doing? Right, I've a bit of an idea, right? There's something to do with like effectively if you have some ellipsoids out in the scene, right? And your camera is originally looking that way. Beyond, um, you know, if you were to make it look downwards, the distance in which along camera or the rate the where it's looking, right, the distance away from it along this camera along this any of the pixel rays, they're gonna be the distance along that ray where they are is basically zero or whatever, right? So I think the more and more it gets like this, the closer these along this ray they get to being at, like, you know, closer to where the camera actually is. But I don't think we have any code like that. But this is something like a suspicion that I have. Um, so yeah. So in view space, the Z of where it's gonna be is kind of zero, isn't it? Yeah. Um, so in view space will be like zero, and you get like. See, if you also have like a negative closest depth, like that shouldn't be a thing. Yeah, so I guess it's sort of making it maybe go the other way. Yeah, maybe we should do minus and just be like, screw it. Yeah. See some of that. Let's see if that fixes it. But maybe I'm just masking the problem. Because I've just made it call them earlier. But it's probably something to do with, we might want to take the dot product. Right, that's got rid of the problem. Right, we could just work with that. That'd be alright, I think. Let's look up. Seems alright, doesn't it? Cool. Yeah, I'm also having fun with my own projects related to games. Nice. What are you working on that's related to game, which is not a game? Um, is it something graphic like kind of like a game engine, but not really for games, that sort of thing. Like something graphics like. Right. I'm just gonna treat that as the solution because I don't want to be working on this today. So I'm just gonna assume that it was the fix and move on. Right. So now we've filled. So remember, every single ellipsoid that we pick up, we go over all of the tiles that it could possibly be on. Oh, I've already fixed this one now. Nice. All the screen tiles that it overlaps, roughly, right? We're more conservative about it, where we over add things to screen tiles, ellipsoids, and it will come at the cost of more checks per pixel. But yeah, it's just the best you can really do. So, you know, the higher the field of view, the more distorted the box will be. We've got a very high field of view right now. It'll be more distorted towards the edges of the screen. We've got a very high field of view right now, but it's only just so I can test the sorts of limits of the renderer. I do not think we're going to be using such a high field of view for the game. Right. But yeah, I don't know if it is a good idea to be doing that, because maybe I'll be fixing more bugs than I need. But yeah, maybe I should just pick a field of view and just roll that. But yeah. Right, so now we've not binned them, we've placed them into the sort key buffer. So let's go to the graphics, just make sure I got the right one because I've got the old code. Right, here's the right, cool. So I'm looking for the tile bin. So all we now need to do is call sort. So we'll do a graphics sort. So this is just support of the AMD. It's open source, right? AMD parallel sort. It's a radix sort. Does it in like 8 passes, I think it does. It does 4 bits at a time. So it's 8 passes. You could probably get less passes if you reduce the number of bits in the key. But we kind of need all those bits in the key. So yeah. Maybe I can look around for another sorting algorithm. There's less copies, but that's optimization for the future. So we want to sort the sort keys. Oh, wait, I need to say with payload. So it's got an accompanying payload buffer where the index, the same index is this is the a value which accompanies same value from the other array. So yeah, you basically get one whole U64 number, but split between 2 arrays, and they're both U32s. But obviously the payload doesn't sort anything. The payload doesn't contribute to the sorting, only the sort key does. The sort entries count for now. We're just going to use this hard-coded array. In the future, though, this will be uploaded from the CPU. And maybe it's going to be controlled via a value set on the GPU. So because we'll have like occlusion culling and that, so it'd be done in an indirect way. When we do have support for that, we have an indirect sort call, which allows you to pass in a buffer to where the count is and the offset into the buffer. But yeah, we'll do that later. So after we've sorted them, now things are actually binned, right? There's actually exists in memory is arrays of different sizes for each tile. Yeah, for each tile there'll be an array, different array of ellipsoids. So the next thing to do is we have another problem, is we just sorted the array, but we have no idea where the array starts for every single tile. So unfortunately you have to run over the memory and just check check the neighboring entries and just check when the tile index changes. But it's not really that simple because not every tile will have an entry. So you can solve this in two ways. If you change the algorithm which finds the start and end, or the start index, or of each array, or you always insert a null entry. In the past, because I implemented this in the past, which we can go and look at the implementation. I opted for the first one, where we search in a little bit of a better way. But maybe there's a better way of doing it. There's this sort of like set up one and then where it find starts. Find starts. Alright, let's try and read and decipher what this code does and see if there's just a better way to do it. I might change it to be the other way around though. Let me clarify that I'm kind of a beginner. Did some 2D game projects. Last one was Asteroids type of clone. Nice, that's a good place to start. But instead of lines, I used polygons. Oh yeah. And had fun with a set algorithm. Cool. Separation axis theorem. Currently playing around with 3D. Just finished lighting and fun model. Awesome. Yeah, it's a good place to get started on that. That's great. Awesome. I'm glad you find the stream helpful. Yeah, that's really great. That's cool. I guess you're looking at getting into graphics then because you're exploring the graphics side of things, or is graphics more of like a means to an end because you want to make a game? I think it was like that for me. Um, and then I somehow fell into becoming a graphics programmer, which, yeah, I came from more of the engine side of things. And then the team kind of evolved into the graphics team. It's cool. So, oh yeah, I got hired for like the graphics side of the company where I work at now. Right. So this sets up. Right, gets the first entry. Spheres, tile bin entries count. Right, so we don't know how many entries are there. Dispatch 4. Right, so it needs to be indirect. Okay, so this needs to happen anyway. Get the sort key. So, alright, so for the first entry, put in. Right, find the first tile. Oh no, I did a fill gaps. I had a fill gap shader. Oh. This ain't complicated at all, is it? Yeah, okay, so I set up the next pass indirect arguments because this has to be launched indirect because you don't know how many entries they're going to be. And then right. Fill in the gaps. By going over all of the tiles. And if one hasn't been filled in yet. Yeah, I don't know why I can't just leave it empty because it's already been mem set. Why do you need to? You just put a conditional at the top, wouldn't you? Right. Yeah, I think this is a bad way of doing it. So, you might not need to fill in any gaps if you already mem set it to an invalid value. Yeah. So we'll take these two. We'll bring them over to the new code base. Right. So this will be known as the tile bin ellipsoids find starts. There's a setup one that will set up just calling the next one. So I've got to make another set of constants. The goal is to make games, but also tools for making said games. I like having a small number of dependencies around stuff. Awesome, same. Sounds very cool, man. Yeah, sounds great. Yeah, I like doing the same. I love making tools. I also like making engine stuff. Tools, yeah. But not really. Um, there's a game industry role called like tools programmer. I'm thinking, oh, great, I get to make tools, but that typically is like build tools, where it's like you're making tools to help people build software. Sorry, to build their code and sort of maintaining those systems and that. And it was a complete. As someone who wasn't in the industry at that time, it was very confusing. I even like applied for a job and actually went for an interview for it, and then I realized, oh crap, I'm in the wrong place. Yeah. Um, I think I can just use the same bundle constants type. I'll share it because I can't be bothered to make more than one. Yeah, I think. Oh, we don't need any constants. I think I got one called no. Yeah, so I have to make the down type. What I need is the globals. All that crap. Good. So that just tells me how many. Right. So of course one like is this a global tile bin find starts in ellipsoids dispatch arguments. So I think we would like tile bin ellipsoids. Say like ellipsoids count. Let's take the maximum, but at least yeah, and then the 0 meaning it will launch 0, divide around by 32, perfect. Cool, so we need to add these to the global data structure, so let's just find that one. Oh, wrong one. All the way over there. Alright. Globals. Here we go. So oh no, there's a separate indirect buffer now, isn't there? So because there's an extra usage flag on the buffer in Vulkan, say it's indirect. Rather than making all my buffers indirect, I have a special one for all of the indirect ones. So I can create this one in a special way in the back end. Because my API is very simple. When you create a buffer, you just give it the number of bytes you want. And that's it. We should probably sort out alignment as well at some point, but I keep forgetting to do that. Or maybe align all buffers to being to being cache line aligned. That might be a better idea. Yeah, why haven't I done that yet? We can look into that. We get some time today. Oh, was that triple L? Right. Cool. So before you run, the tar binning, I need to clear. So there's a thing called like frame in it, right? Entries next index. Oh, we've already got one. Oh, it was right there. All right, that will be good enough. The next index would be the count. All right, so I think we can take that. Put it as that. So we'll print this out just so we can see it. It's probably going to be fine. Right, so there's the setup function. So the find starts is going to go over all of the make this. So where's the tile bin? Here we go. Let's take all this. Rightio, so what do we need? We need the sort keys and the start indices. Tile bin entries start indices. Something like that. Entries start indices. So we need another buffer. Cool. Neat. Right, so next thing is to get the ellipsoids count. So we'll put that. So we're looking for pairs. Oh. Oh, pair start index here. Um, oh, maybe we need that code back. Yeah. Right, that code where it finds the first one. Right, we'll sort that out. Sort key. Right, so use the same constants thing. So sort keys. So the first sort key, whatever that tile index is, insert. Yeah, set that one to 0. The next thing to do is you get a pair. You shift out the the tile index, which is 16 bits now. Then if they're not equal, we found a boundary. Let's just do a for loop. All we have to do is just do one of them now. I got to remember to do the mem set. So it'll be whatever tile index 1 is. Yes. Neat. Cool, so that'll be the logic for finding whether they start. Just go over the whole buffer and check a pair of entries. Yeah, it should be alright. Right, so we definitely need to mem set. This sort of code here. So before we do any of needs to mem set the start indices, so I need to actually make that buffer as well. Tile bend ellipsoid start. We need to actually initialize these as well. Alright. Good. Right, so with this mem set, we'll clear all that to U32 max. So if we start a tile and it's equal to U32 max, we should just be able to stop rendering right away. So we sort then we dispatch to compute shaders. So sort keys and start indices is what we want. So they're read write. Entry start indices good. We'll launch 2 compute shaders. One of them is the setup one. And the other one is indirect. So this one just launches one thread. Be careful this sync code. You know what? I'll copy paste it because I'm gonna get bugged otherwise. Right. This one also, they also need to sync on global, isn't it? Right, so this one reads and writes. Does it write? Right, it reads from. There's an indirect buffer as well. Yeah, so it reads from this, writes the indirect buffer, then it reads from the global's buffer, and the indirect it'll read from when we dispatch it. So the beautiful thing is about this is we just have to provide an offset because we only have one indirect args buffer. So we in the back end of the GPU layer we just have one. It already knows what buffer to look in. Yeah, so we'll do graphics, indirect args. I don't know what it's called. There we go, one of them. Don't need the size anymore. Cool. Right, so that should be what we need to get all the star indices found. I guess let's give it a go. We could, I could bring back those print statements. So I could print out like in the shader found entry or found tile this tile starts at then that entry there, yeah. So you'll just be tile 1, tile index 1, and then pair star index plus 1. So we try that. We should at least see see the arrays in action. I think they should be ordered as well. So we should be able to verify what's going on a little bit. What did I mess up? Alright, hopefully that works. Hey there, Dios. How's it going? How are you? Right, these are not... Oh, they're meant to be sort of graphics CS, isn't it? Whoopsie. The compiler just takes the name of the shader and makes an enum for it. Crap. Oh crap, I completely named that terribly. Cool. Fingers crossed, here we go. And what do we get? Right, a bunch of printing as we expected. The best we can just do is pause it. Have a look. So we've seen a bunch of sorting happen now. Right, there's all the... Yeah, it's quite a lot of shaders that runs to sort the whole buffer. It's all quite small because we don't have a lot. But... Yeah. Want to be careful of those sorts. Oh yeah, I don't have that much of a big scroll thing, crap. Right, so there's 612 entries being put in just for that. Seems like a lot to me. Not gonna lie. But if you have a 16 by 16 tile and you've 2 dimensions, right? So all it takes is an 8 by 8 set of tiles to get you 256, right? So 8 by 8 of 16 by 16 tiles, it's I already get you 256. Oh no, sorry, sorry, 64 on it. Yeah, so it only gets you 64. So, and we're only inserting, how many are we inserting? Did we insert just one ellipsoid or 2 ellipsoids? No, we're putting 2 ellipsoids, so they get you 128. Yeah. So, I don't know. Let me take a look at what's going on. Um, I guess so, right, so we're adding. So we could do instead. Is not print this because there's so many, or we could at least. Oh yeah, disable this code. Right, let's re-enable this drawing code. And we can just count how many we got and we can see, right? Right, so what is that? There's 4. Alright, it's a bit slow. But anyway, 4, because it's rendering. These things just take, they're quite expensive to render. So 4, 8, 12, 16, 20. Let's just say 20. And then 4, 8, 12, a bit. So let's just say 20 times 14. 280 tiles times by 2. 500 and. Yeah, there's 640, so I only counted 560. Oh, let's try that again. 8, 12, 16, 20, 4. Oh, it is. 8. 12. Yeah, 14. It was 14. Yeah, so something's a little bit fishy here. Why is there an extra sort of like 100? Entries unexpected. What's going on there? So it's doing an atomic add. So we'll increment. So I've only got 2 ellipsoids, so I guess the next thing we can do is let's literally just print out ellipsoid index. We'll say ellipsoid blah is in that many tiles. And then we'll just comment out these things because they just print so much. And Let's just see what we get. There's only 2 entries right now. Alright, so apparently... Oh, okay, so of course, the one behind it is more. Takes on more tiles. Okay. Cool. Seems alright. So I think we're like... Yeah, so the best we can do now to test this is... That's going to work well. Is simply only have like 1 entry or something like that. And make it small so we can literally see the ones it's going in, and then look at the start indices and make sure they're good. So I need to make sure that when we upload them from CPU side, that we don't include this other one, and maybe we'll make this one smaller. So it is kind of scaling. So maybe we'll say, you know what, you are 0.5 in size. So that should be all enough so we can look at the yeah, there you go. So it's that little rectangle there that should have very easily countable number of tiles. So right, 16 times it's been binned. And these are the different tiles it went in. And as you can see, they've only got the distance between the arrays is only 1 entry. So they're just literally right incrementing by 1, which seems good. We could test it one more time where we bring back, or we literally just duplicate this thing, right? Let's just do it another time. So there's 3 of them now. So what we should see is actually they're all in the same place. We should see the arrays each be 3 in size. Cool, let's have a look. So that's not how it's ended up. There was 16, right? So that is times by 3. Although the tiles that have been unit 4, 6, yeah, they're right. Oh, why is that duplicated? It's as if they're not being sorted. Not good. Yeah, so we saw a duplicate entry. So that is probably... I don't know, why is that caused? Oh, watermelon. I only sorted the first 3 entries. You probably would have seen that bug in the first time around it. So this actually needs to be indirect from the get-go. It's alright. We've already got a thing for it anyway. So it's going into the buffer it's going into is the global buffer, right? Global oh my days. GPU global. Yeah, so we just got global buffer. It's just a structure. Put whatever you want in there. Every shader can get it. Hang on a minute. Yeah, then the offset is offset of that lovely graphics global type. And so Entries next index. That's it. That's it. So that's the offset to it. So that will get it. So let's just put some new lines in there to make it a little bit more readable. Yeah. So that's the actual count, and it'll be like that after this one is finished. Let me just double check him. It definitely syncs the buffer, right? Read only. Perfect. Cool. So let's give that a go and have a look at the console output. Globals. Taking oh yeah, I remember this. Sometimes that window freezes. Right, cool. So we break that now. Cool. So it's stepping by 3 now. So they're all being actually binned. So we put 3 spheres down in the exact same place. And then they all got made into entries, and then the entries got sorted into tiles. So now you got a linear set of array of 3 entries each per tile that this overlaps. And as you can tell, there's a lot of tiles just for a small portion of the screen. So I really do think we've got to up it to 32 because it's a lot. The whole point of having tiles is so you group things together. Yeah, there's definitely a trade-off. Maybe we just need to play with it when it's done. Right, so now we're officially binned and we can actually get using this thing, which is super cool. So in our 3 different ray tracing shaders, ray trace anti-aliasing, MSAA multi-sampled anti-aliasing, and super sampled anti-aliasing, we are going to switch over to getting our ellipsoids from this array for that tile. So I don't know how I'm gonna find. Yeah, I don't know how I found the end of the array. I must have put a count somewhere. I'm just this is the previous code base. Let's just look for ray trace. It's got tons of little ray trace code. All right, tiled. Here we go. So, what a clever clogs I am. So this is why I wanted to fill in all of the entries, is so I could know where it ends by checking the entry to the next tile, and or if it's at the end of or if it's the last tile, let's take the maximum number of entries and use that. So that would then, right, but I haven't done that. So I've got 2 solutions, right? I can either put a null entry in, so you loop until you reach null, a bit like a string. You loop until you reach the end. Or you could try and do something like this again. I think this is, this how many tiles we've got. So we've got, 4K divided by 16 at the moment. That's 256 times 256. So that's 64K number of tiles. So that's how many entries you will be adding. to be sorted if I was to add a null entry in, which is quite crazy. But I don't really want to fill in all the holes either, but we could fill in holes. We at least need to know where the end is. So we could set an end indices array as well. Yeah, that's what we'll do, I think. So I think the be too bad. So, yeah, you just set an end indices array. So it's like this. So, yeah, it has to be U32s. Yeah. So you just be like, well, yeah, that's all you do. You just set an end indices array whenever you find a new one. The problem is you also need to get the last entry as well, which isn't too hard. So I want to say set the first tile, set first tile, start index, set last tile, end index. So you would get the final tile is like make it exclusive end. Crap. Yes, you get the last entry, fish it out. Nice. Cool, so just gonna make another array now. In here. Yeah. This just holds all the end indices. It would be nice if we could join them together, or they could be smaller, but well, they could technically get joined up. It's probably better for performance if they're joined up. You'll get a couple of cache misses rather than just the one, because they'll be next to each other in memory. You want them. Yes, I think you want like a range buffer. That's what you want. All right. Ranges. Ranges buffer. Ranges. This is going to be size of, well, Can I be bothered to make this drop? Not really. So let's have a pair of indices basically per one of these. So all we do makes the code a little bit less readable, but can't be bothered. Times 2 plus sorry, I've got a comment to explain what's going on. It's better with a code. Yeah. That's great. We'll make a strut. It's gonna go in the shared header, isn't it? Alright, GP. We can call it a range. Wait, I've already got a range of 32 in it. Interesting. Why haven't I got these on the GPU? Where's the core shared? Alright. Got myself Stry. So CPU side. Oh yeah. Okay. Then there's times 2 plus whatever. It's now a bit like English. Rather than just trying to understand what that means. And start. Cool. Right, so oh crap. Yeah, so if this runs, then all we have to do now is make the shaders use it instead. The ray tracers use it. Cool, seems to be right. Let's go ahead and restore the previous one. Right. I'll just take a quick little break now. Yeah, a couple of minutes. When I come back, we'll sort out the we're gonna make the ray tracer use this array for the pixel. It'll check what tile we're in, and we'll fish out the array of ellipsoids to render. Right. Okay, I'll be back in a couple of minutes. Alright, welcome back everyone. So, yeah, I think that'll work fine. Cool. Yeah, so in the ray traced anti-aliasing shader where we ray trace the ellipsoids, um, let's add a new maybe we shouldn't call these entries. Bit of a terrible name. We should call them like ellipsoid ranges. Yeah, let's do that. So, ellipsoids ranges. Cool. So I'd like to do that for this one of the ray tracer. We'll put it as read only. And we're going to go inside. We've got 3 different ray tracers, right? SSAA, MSAA, and RTAA. Let's go to the RTAA one. That's one we default to. And let's. Oh, wait a minute. I didn't do the. Add that to here. Right, so the output texture, the output depth texture, and the ellipsoid ranges. So now we should be able to get rid of this array. Might be quite crazy. And we should be able to use let's go back to the old code. Just get the maths for it. Because I can't be bothered to type it all again. Yeah, I want to get start index and probably a count. Something like this. So we'll rework this code. So we need to work out our tile coordinate. It needs to be divided by the tile dim. So actually, we need to read global. We're not read only in global. This is so error prone. I need to get this automated with my compiler. Ugh. Right, so we read. So the tile dim. So in the globals buffer, there is a. How many damn files? There's a. Ellipsoid tile dim. So how long across a single dimension, or how many pixels is a tile across a single dimension? So yeah, we can change that. It's hard coded 16 right now, but it's passed around everywhere, so it should just scale. So we actually want to do probably a div s divide scalar. Let's make that a little easier to read. So just divide by that. So round down, and that would be our tile coordinate. And then we take the coordinate, we flatten it. So it's called grid dims. So the grid of tiles, what are their dimensions in 2D? We flatten it out. That gives us a tile index. Now we use the tile index to fish out from the ellipsoid ranges. We fish out. That's right. Right, we want to know. Yes, we get the start index. No, it's an actual range, isn't it? Core range E32. Range. Nice. So nice. I don't know if we need a spheres count thing. We can, or sorry, ellipsoids count. It used to be a sphere renderer. Right, something to just quickly double check in our memset code. Yeah, this just memsets the whole thing to U32. Every scalar fill buffer. Yeah. Good. Right, so got the range. So we set up the ray tracing, right? We get our world space coordinate, we get our world space direction with a ray for this pixel. So, right. Then it would be this E index thing. I've got to be careful. Yeah, maybe we need ellipsoids count. We like range dot end take range dot start. Then we'll go over this many. Then there's like a binned ellipsoids thing. Ooh. Yeah, so you got the ranges. Then you've got, there's a lot of indirection here. Then with that you can get the range of ellipsoids. The ellipsoid indices. Your range of indices, and with that you can fish out your actual ellipsoid. It does kind of suck, they are kind of not in order. But you'd have to move a lot less memory doing it this way. Maybe there's a way to preload it, because since per tile you're sharing the same amount of ellipsoids, maybe you could preload it into LDS memory, and that could probably give you an improvement if you end up loading the same amount of memory as you would have anyway, probably. Because the problem is if you hit the first entry, there was no need to load the rest of the memory. So yeah, be careful about that. Maybe this is fine. So CPU side, we need to pass up the sort, the payload. How's the payload? Read the payload. Nice. We need the ellipsoids as well as the binned ellipsoids. Right, so they're passed into the ray tracer now. Then the ray tracer. Oh, right. So we get our sort of like ellipsoid index by looking into the array of ellipsoid indices, range.start plus the E index. Then with that ellipsoid index, we can look at the ellipsoids. Yeah, so there's a level of indirection now, which kind of sucks. And that gets you the binned ellipsoid. Now this thing could be deleted, structure, but we need to... Where does that one exist? Ah, graphics binned ellipsoid, RTO. Cool, so this should be it. And then we're just in the regular sort of, we transform back into the local space of the ellipsoid, do the ray trace. If we do this extra stuff, I'm hoping to minimize this a bit more in the future, but you what's he complaining about? I need to get back onto onto Linux, so we have proper error messages from my compiler that show up. Or from local field. Right. What do we call that? Or from ellipsoid. Hey cat. Yeah. I want to escape. But tomorrow I got my new drive coming. I ordered a new M.2 drive so I can you know, the existing one that I have, which is toast, I can keep that around for backup just in case I need something off it still. It's great. It's a bit costly though. I have to buy another M.2 drive, but they're pretty cheap these days. I've managed to pick up 1 terabyte for like £66. So, I'm willing to pay that price, I think, so I can move over quicker. I have a weird grub boot at the beginning of my Windows build law. Have you tried Debian? Had no drivers for AMD? No way, must have drivers. Huh? It must do. It's built into the kernel, right? Weird. Hmm. Yeah, so install grub on the yeah. Nice. Hmm. Yeah. Right. Oh my days, it's working. Would you look at that? It's looking a bit blurry around the edges. The RTA is a bit too good. I need to fix it. But it seems to be working. So these are the two ellipsoids that we're rendering from that we're issuing to be rendered from CPU side. Um, so yeah, it's working. Um, but yeah, as soon as we get this into the bounding box of it goes into the camera, it does disappear because of the clipping. But we're for this game, we're probably never gonna need that feature. Oh crap! Right, I think we're still alive. I think we got our first GPU crash on this card. Did we get device lost? Oh no, we didn't. Because this is not in the Yes. Yeah, I think we got device lost. Perfect. Yes. Yeah, so on Linux, the drivers are built into the kernel. You still have to download a userland part of the driver though. But that's usually packaged with the Linux distro. If you use Arch, you have to manually go and get that. But yeah, there's like a kernel part of the driver, and then there's like a user space part. Um, Something like that. I forget the specifics. Um, yeah. Yeah. If you just use a distro or Manjaro, that's another one that comes built in. Yeah, it will just work out the box. That's the best thing about AMD is just it's integrated into the kernel. Whereas with NVIDIA for the longest time, theirs theirs is not open source. But so what would used to happen is um inst you would get a new kernel update, and the closed source driver would have been built against the old ABI of the kernel, um, and then it wouldn't like work. I think it was like a kernel module or something. I forget. I forget how it works. Um, yeah. So what would happen is you would have to downgrade your kernel to get your proper NVIDIA driver working again. So what they've done to get around that is it's still closed sourced, but they've open sourced the kind of interface layer, so it can keep getting updated. But they've moved more of their driver like into firmware or something. I forget the specifics. So I think they've fixed the problem now for Nvidia, but I don't know. But AMD is still going to be the best option for running on Linux in terms of compatibility, because it's actually in the kernel fully. Um, yeah, it's interesting. So I got so close to the screen that it's I don't know what I did. Well, I went through the second ellipsoid and it was like no. Oh, you know what it is? I didn't check. Yeah, there's an index out of bounds. But, so that second ellipsoid, so what I didn't do is go, well, if range dots, if range dot start is equal to U32 max, that's what we didn't do. And I guess we want to say if either of them are, although it is an extra check, do it for safety. I think that was the problem. Yeah, then if this works, we should upgrade our MSAA and SSAA shaders to do the same thing. Oh, oopsie. Right. So as you can tell, only the tiles. This is an interesting debug view. That only the tiles actually render anything. That have ellipsoids in will render something. Yeah. So what you need to do instead is say if Right, I wonder, right. Oh, 0. Should be it. So you should be able to go through this ellipsoid and go through the other. We'll look at performance as well. No, we crashed it again. Another device lost. Let's check the other shader. Ah, that's problematic, isn't it? Right, so we want to say if this is 0. Always a useful thing to keep around. We'll do take 1. We still need to set the indirect args though on an else. 0 so it doesn't launch. So I think that's what was happening. You just have is indexing with a -1 and writing to it. So it would write 4 gigabytes ahead or more in memory. Or 16 gigs, because 4 gigs times 4. That might be the problem. See, thankfully, we've got this new card now, because now it doesn't bring down the whole Windows machine. And there we go, it just worked. Cool, so I was able to go through it and it. Yeah, good. So, right, I guess. Right, cool. So yeah, let's sort out our other 2 ray tracing shaders to just get this working. And then I want to look into aligning our Vulkan memory to a cache line. And maybe we'll look at this profiler on the left and see if we can make it a little bit nicer to read. Or at least work out what can I do to make it a little more readable, because we just dispatched a whole ton of like a whole load of these sort things just appear, right? If maybe we can condense those down and get an overall time, because that's like very difficult to work out. It's a bit like a shopping list, trying to figure out what things add up to, because there's lots of small numbers that just accumulate, right? So yeah, maybe we can look into something like that. Yeah. Cool. Yeah, so let's start with the SSAA, supersample anti-aliasing. Excuse me. But no, might help identify bigger issues, perhaps. Consolidating numbers, you have less than 1 ms. Yeah. Problem is, what would you do? How would you do that? Would you check string names? Like there's ways where we could do it, where we could introduce like make it like a tree basically. Put some start and end points around a dispatch, and you could build like a tree of these things, and then you can maybe open up different sections. But it's printed out into a terminal, so you know if I did a tree though, maybe we don't have the ability to shrink it. It's always expanded, so you see it all tabbed out and things. Um, but yeah, that might be the approach that we take. Yeah. Or the other approach is we draw something, we press a button, and we open it up in the. We actually see it on the screen in the game. Just got to figure out what's easiest to do. Well, the first one's easiest because the second one probably depends on that. So yeah, let's do the MSA A one first because the other one's got a structure at the top, and I'll forget to delete it, and it'll just stay in existence. So if I find if I nick that code there, and drop at the top here, delete the ellipsoid, hard-coded ellipsoids, then right. So deduplicate a list of ellipsoids that have been hit. Right. Yeah, the implementation can be improved at some point, but we're not concerned about that just yet. Deduplicate a list of hit lists. Each E32 stores front to back sorted 8 indices that deduplicate into the deduplicate list of ellipsoids above. Cool. Go over all the subsamples for this pixel. Now you need to fish out the ellipsoid. So hang on a minute. Let's get that code. Then this needs to be world from ellipsoid instead of world from local. And then, so that will be fine. So it does, when you get a hit, it does its deduplication, which is kind of expensive, and I would like to improve that. So I'm not a big fan of branches, big branches. But yeah. Then after you've done the sort of rasterization part, we perform the material. Let's just get that. We perform the material samples. Once. Sample each hit surface ellipsoid once. Even if multiple subsamples. This is the optimization, right? You're only doing the material calculation once per ellipsoid. That's what makes it MSAA and not SSAA. Even if multiple samples hit the same ellipsoid. Put a comma in there. Nice. So neat. The next thing is you go over the hit list. You go front to back. And all you're doing is blending front to back. All of those things. Hang on a minute, I'll just copy. Okay. Blend front to back in the hit list. Okay, go over every single hit list. And then every single hit in the hit list. Accumulate the, or blend the color front to back. And then put the sky on there if you still need to, if you've got something that's a bit transparent. And then add it, accumulate it into the final color, and add the weight in there. So if multiple things hit the same surface, the weight would be a non-1 value. Maybe more than one basically, and then we do a weighted average here. So we want to say loop over each hit list. It's kind of like a unique hit list. Deduplicated hit list, and blend the hits front to back. Then accumulate the color and weight. Based on how many subsamples share the same hit list. Cool. Yes, I think that's the logic. So let's give it a. Oh, I've got to go over to graphics and put a 1 in there. So now we're using the MSAA shader. So let's give that a run. Hopefully it works. Right, it seems to be rendering something, and yeah, it's running the MSAA shader. So there it says there MSAA. Takes 2 milliseconds here. As we get closer, it'll probably take longer. But yeah, that seems alright. I can see it's MSAA times 4. So it's got some nice anti-aliasing going on. But yeah, I'm not seeing any particular problems with it. Oh. Right, I think that's just a problem with the oh, I did an any, didn't I? Yeah, I think I said if any of them go out of bounds. Yeah, I think there's generally a problem with the actual oh no. Oh, what's going on there? Right, we'll put the box around the second one at some point. Let's just we'll come back to that problem. So let's do the subsample anti-aliasing. This one is just a simpler version of the MSAA, because the MSAA is just an optimization, right, for SSAA. So it's doing super sampling, but without actually sampling all those materials again and again and again. for each subsample. So I can now delete this temporary structure. We just got to go ahead and fish out those extra loop. Oh, sorry, this different type of indexing. Right, so for every single subsample, and then for every single ellipsoid. Nice. Fold from ellipsoid. Nice. Right, then afterwards, so for this single subsample, we got a hit list. We then go over the hit list to properly and perform the front to back blending. Sorry, yeah, we work out the material color and then we front to back blend. This is so we can increase the wave occupancy. So this if statement is as small as possible. Yeah, and hopefully the neighboring pixels in the same wave have the same number of hits, hopefully. Even if they didn't hit the exact same ellipsoids, they maybe hit different ones. But maybe not. Or at least they'll have a closer number of hits. I think that's everything. Let's give that a go. Let's give that a launch. Right, so this is super sampled anti-aliasing. So this would be the best looking AA, but the most expensive. Because it's literally rendering high resolution but not saving out the high resolution image. Instead, it is downsampling it before it even writes the pixel up. Cool. Right, so it's quite bad actually. Cool. I guess let's fix that bug now. So that's good. We've literally just got the tile binning complete. So we'll switch back to the RTA because it's just quicker. And let's investigate that one bug. And then we'll look into aligning our buffers to be cache line aligned because, buffers are typically, they're going to be, most of the time they're going to be big and not small. And aligning to 64 bytes is not that bad of an idea. Because I might think, I keep thinking about my data structures being like a cache line or whatever, a multiple of a cache line or something like this. And if they're not aligned, yeah, they'll potentially go over. Yeah, they'll potentially not be aligned to a cache line when they're allocated, meaning actually they're going to split into two cache lines, and it's not instead of one or something like this. So yeah, we're gonna be on top of that. So let's go to the where we do the actual binning. That bug. Oh, this is the old. In the old, what's this? Oh, this is UI. Whoops. Ellipsoids, right. So I want to enable this code actually for the other one. So it's just going to debug draw the screen bounding box for the ellipsoid at the back. So here it is. Yeah, so it seems right. Okay, so it seems that it actually extends really. The box extends to be very, very tall or something like this, and I think. Well, okay, if it returns early, then this wouldn't render actually. So let's see that again. If the box disappears, then it means it is returning early. Yeah, it's probably to do with I've got code which checks if the rectangle is going off. Yeah, just disappeared, right? I got code to check if the bounding box is off the screen and therefore don't render it, but I guess I'm just doing that a bit wrong, isn't it? Yeah, there you go. Cool. So that's all it is. It's not this one because this is the far plane. This one's either behind the camera or out of screen bounds inside this function, which calculates that screen bounding box from the local space, the 3D local space axis line bounding box of the ellipsoid. So in here, there's a bit of code. Yep, and I just got this wrong. So if the minimax point goes past, if the max point is less than, or if the min point is greater than, hmm, yeah, I don't see that being a problem. So I'm saying if any dimension of the screen dimensions is, if the minimum point is greater than, so if the x goes past the end of the screen, right? But maybe because maybe something causes the values to become kind of invalid. Yeah, so I guess the best thing I can do is split this into two, and then simply just put a print statement in and figure out what the hell we hit. Um, oh yeah, I've got to have at least one. Um, my GPU printf is some hacky macros, so it kind of expects there to be at least one parameter. I could probably make it better, but I just haven't bothered, I guess. Why are you complaining? Oh, you're in core shared, isn't it? Right. This is not available CPU side and it's shared between CPU and GPU. So I need to if def HCC. So only rate gets rendered in. I'll put into the shader compile. No. What you talking about? Oh, it's not. Ah, for crying out loud. This is before. Right, well, how does. Hang on a minute. Let me just. That might not be declared yet. What number is it? 0, 1, 2, 3, 4, 5. Alright. That'll do it. Ugh. There's the hacking macro. How do I include HTC shader? 2 secs. I guess I do it. There we go. This is how you get some printing work in GPU quickly. Right. I can't see because there's so much profile information happening. Great. I could disable. I could minimize the profiler. Hang on a minute. Yeah, we're gonna have to do that. So in graphics profile mode, we'll turn that off, and then it won't set it to individual shaders. Instead, it will just profile the whole frame. So it won't tell us what each individual shader costs, and therefore actually see some stuff in the terminal. Right, here we go. So what am I looking for? All right. So I'm looking for when this goes off the screen, how is it culling it? Well, apparently, right, we see it there hit 0. Now we go that way. It should be doing hit 1, but it's not. Actually, bit bizarre. All right, let's go back to the code and see what's going on. Core shared, right? Okay. So I feel like we should be able to print from here. So we should have. Oh, it's just yeah. I think it's possible. But right, it's hit 0, got hit, which is where it goes greater than, but the less than, I couldn't seem to get king there, wasn't that right? So what else could we print? It might be useful. Now we're going to see this get printed twice actually. That's the problem with it. Right, so we're actually going to see it for both ellipsoids here. Maybe we can work, well, decode what's going on. Oh, sorry, this has got to do this silly thing, and I. Hey Lupo, how are you doing? Welcome, sir. How you doing? Yeah, I'm not doing bad, thank you. Not doing bad. We just got these ellipsoids bending into screen tiles now. We're just doing a bit of a bug fix towards the end here. But yeah, so we should ideally be able to push more ellipsoids now, and performance should scale a bit better. It's gonna scale more evenly. Um, but yeah, we've still got to add model instances. That'll be the next thing that we do actually is make model instances work, because right now we're just putting ellipsoids on, but you'll have models of ellipsoids and these will get binned instead, and then we'll be able to occlusion cull everything as well. That'll be the step afterwards. How do you like the new bigger video player? What big video player? The Twitch one? I've not been on Twitch to see it. Is that what it is? So we're getting 4 numbers per now, which is 2 per ellipsoid. So, but if we go that off the screen now, we're only getting 2 numbers, which leads me to suspect this actually gets culled in a different way. Right, it's because the front of the box is behind the camera. Right, that was a problem, wasn't it? Alright, so actually, to do like a nearest depth. Oh, furthest. That's already right. Closest far depth with near depth. So we get far depth plus, and then we'll clip. But then we've got that other bug still, and that's because the near depth ends up being before the camera, which can cause the divide by z of one of these guys to be yeah, so we've got to resolve that problem again. Let's just take a look at the results by undoing that the fix that we did. We've got to solve the first problem of the day properly this time, rather than cheesing it. It actually had an impact. Yeah. Yeah, so when this becomes perpendicular, right, this one's a bit different because this is, yeah, anyway, it does it this way around. Ugh. Right. It's difficult to know which is which sphere. Um, difficult to know. Change it to the worst, or no? What? Minus 14 degree cold, wow. Chilly. I don't know. Is it really minus 14? Like, or is that literally minus 14? That is insane. Yeah, I don't know how people do it. Yeah. I guess it's just like if you keep fit, the younger you stay and the less or the younger your body kind of stays and the less issues you have. It's as soon as when issues start arising in your body with your like joints and stuff is when those things typically become problems, right? And obviously they got minus 14 is too cold. You cannot play at that, right? That must be impossible. Um, yeah, you definitely got to keep warm. You have high chance of injury, isn't it? Um, so there was that problem with the. So I think what you can do is you're going to get a center position which is basically zero because you're perpendicular to the, or your view is perpendicular, right? So you got your two spheres like that, and then here's the camera. Well, what happens if you turn it to look down instead? Well, instead your ray's going that way, and then so positive Z goes this way. So in terms of like where are these spheres on the on it? Well, they might exist between the far might be here and the near might be there, but when the far is greater than the sort of flip plane, then it's accepted, so it could still possibly be rendered. Um, then it means that um, some of these coordinates will have been so I think more specifically this these near ones, important near points, those would have been divided by z, which would be negative. Will that be what's going on? Divide by -2 or whatever, right? So that'll produce you like a negative coordinate. That should be alright. I don't know though. It's difficult. I think yeah, let's just render the one ellipsoid because I cannot figure out which is which in the prints. Um, Kelsey 131 though. Neat. Congratulations. Yeah, so I want to comment out this one. And then we can actually see the numbers and how they behave when they go off the screen. Like, do they become negative and if so what like or Well, that one even goes off the screen there. That's not great. Right, so one of them is negative there. And they're both negative there on the min. Max position. Oh, it just snaps all the way around. That's weird. Then max value there goes to like 60 or 1,000. Right, so they're both out of bounds there. So only when they both. I've won any though. Oh yes, that min, isn't it? Hmm. Right, let's take a quick break and then we'll come back. Fix this bug here. BRB. Right, welcome back everyone. The frame rate increased from 2 to 3 milliseconds, right. Yeah, I still didn't get why that would be. Okay, so let's see if past Henry has solved this problem. It's always a good shout. So what I did in the past, I call it screen bounds. I used it in the occlusion stuff, right? We generate the occlusion buffer stuff. Yeah, so we'll be redoing this again very soon. After we've done the model instancing, we'll be doing an occlusion buffer. Right, reproject depth as occlusion. That's not it. Where do we render into the occlusion buffer? Occlusion buffer, right. Is this it? No, I think it was the volume sphere. I think this was it. There's a function. Outer screen bounds of 3D ABP. Yeah, so I could have swore I come across this problem in the past. Right, calculate the closest depth differently. That's debug drawing. Right, it's not right. I don't think I solved the problem in the past. Right, so let's see if we can think about a solution. So the problem is when you start looking. Wait, we need to draw the Let's investigate a little bit further first before we think of a solution. I'm trying to understand the problem a bit more. Also, these startup times are way longer on Windows. Ho ho ho. Right, so we can actually see what's happening with the box. Right, so technically it's going behind the camera. And then it's inverting it. And then right, it's behind the camera, so we get... Then the full thing's behind the camera, so it actually doesn't do anything. Because that's the far bit. Right. So if the near bit goes behind the camera, I think what we want to do is clamp. I think we want to clamp Z near or something like that. Then if we clamp it to near, we just... Then we're not getting proper values. But then, why would it... Wait, this is the wrong code. Alright, I got ideas. So... Right, so say if the camera was looking this way towards the spheres, but now it's looking downwards, the near is actually negative, so it's causing. So when you divide divided by that negative z, it will flip the x and the y axis the other way round, and then it will cause them to essentially shrink back down again, right? And it mirrors it back essentially. So um, something like that. And then until the far gets behind the camera, then it will actually clip. Well, the near clip position, not the camera, but the near clip part. So we could clamp the Z of all of these. So negative Z. Oh, wait. Yeah, then you want to say clamp. Let's try this out. Dot Z equals maximum. Sorry, not Z. XZ. Maximum of. Near clip plane distance and right, so when it does a divide it might but the far z should never go before that, because if it does it would bail here, right? Wait, so the near z for these are all the same, isn't it? Wouldn't ABS the half dims be why am I ABSing this? Oh, but if the center position goes before the if the center position goes before 0, it's going to flip the Z. Interesting. Right, so I think this wants to be the near Z. Right, so this should actually be near Z instead. And then probably get away with this being a vector 2. You probably don't need ABS anymore. You could probably get away with saying dot xy dot xy, right? Then to get the four most important points of the axis line bounding box in view space. So it's three of the front ones, depending on which corner of the quadrant of the screen it's in, and then one at the back, which represents the far point. So I think it was flipping the Z Those, yeah, it's getting double flipped sometimes. Or being the wrong Z for these near and fars. Yeah, and this could be a problem too. We can double check that after. Right, and I think it's still a problem. Yeah, so this should be the fix. No. Right, we did change a few things. Right, it still kind of occurred though. But it was far worse. So, right, whoops. Hang on a minute. It is silly. Uh, yeah. Right, so I still think these still need to be IVZ, but IVZ. IV.xy and IVZ is equal to half dim Z. Right, it's the problem because near depth was center position take half dim Z. There's too much. Right, there we go. So that's restored that to being okay. It's okay. It's over expanding like this. It's supposed to. Wait, is it? Yeah, maybe because it's the high field of view. Um, right. So the great thing is that it seems to be working. So this is not expanding off and coming back. It seems to stay clamped or something like this. But there is when it ends. The min point, hit 0. And then when it goes off the screen, hit 0. Good. So that's when it gets taken off. It doesn't render. Good. Right. I think we got it. Yeah. Right, it is discarding. That's really good. Yes, I'm curious about the bounding box. Bit excessive, right? Something's up with the bounding box, that's for sure. It's a bit too big. Ridiculously big. Hmm. Right, so we'll quickly debug this and see why it's getting so big. So I'm happy with where we got for this part of it at least, but there's something to do with the bounding box. So we can debug draw this one. Draw 3D AABB. Center position and half dims. Border thickness we'll do 0.1 I guess. And then a color of -1. Z test false. Just draw on top of everything, please. Maybe we'll make it red. So yeah, I don't think we need any of these prints anymore, but I guess we'll keep them there just in case I want to debug print anything. Oh, this is not accessible, is it? 2 seconds, let me forward declare it. The way I include my headers is not good at the moment. Well, this is in the core side of things. So maybe I need to make a different header for geometry and stuff like that, so we can debug this stuff a bit easier. Hmm? Don't do this. Oh, I just closed the wrong down window. Well, um, right, share between CPU and GPU as well. Okay, here we go. So there's our view box. There's a view space align bounding box for this ellipsoid. Right, we could get a right, I see what's going on. It's because the high field of view. It's understandable. So it just tilts really far because it's quite long at the back. Yeah, that's all it is. Just tilts a lot. That's okay. That's acceptable. We're not going to probably have a high field of view anyway, and stuff this big. That's great. Neat. Right, I guess let's investigate some of those other things we wanted to deal with. So I guess we can tick this one off that we're done. So I want to look into aligning my buffers to a cache line. Hang on a minute. Let's join these two up. Cool. Yeah, I want to do it in my Vulkan backend. I've got a custom memory allocator, right? Why did I just CPP that? Right. Hopefully you didn't see me PP. So there's a Vulkan internal side of things right here. We added a memory allocator because we wanted to do temporary resources. So we needed some kind of like heap allocator. We could free resources before the end of the frame and reallocate them again, which is pretty cool. But we didn't take in some required alignment. So in the heap allocator, what I want to do is there's some alignment that gets passed in. Oh, no. So if we just take the required size, align it to 64, and then every allocation align that to 64, you know, a cache line. Maybe that's enough, but also, sorry, that's heap alloc. Hang on a minute. Right. This one, Vulkan memory alloc, we pass in size and line. Perfect. So I think when we look at these, they're going to be like, yeah, like 4, right? So they're like buffers. 256 is probably a texture. So what I would like to do is go a step further and be like, right, so these are called when we do allocate buffer memory. Well, yeah, maybe I only care about it for buffers actually. So maybe we say align both of these to 64. So core in roundup align. So rounds up to nearest alignment to a cache line. So that'd be 64 basically. So we round up our buffers. Yeah, so aligned to a cache line. Neat. So we put a breakpoint in here now. Take a look at it. That should be a bit better. I'm not sure we're going to see any improvements doing that. Wait, is this of an image? Right, that's questionable. What happened there? Oh, no. Is it? Yeah. We looked at the size instead of a line. Right, so a line should be 64. Yeah, so a line is 64. And the size is a multiple of a line. Cool. Neat. So we're going to waste a little bit more memory, but things will be aligned. Hopefully be more performant. Doubt we'll see any improvements, to be honest. Yeah. It's too small and to understand what's going on anyway. Cool. The other thing I wanted to fix was the profiler. Now we're using parallel sort. The profile that's printing out into the terminal is way too long. I did disable it for a second. Let's re-enable it. Well, let's just double check we fixed that bug. Hang on a minute. Yeah, so draw that ABB. That'd be good. Right, we look down. Sweet, it's fixed. Yeah. Right, okay. Alright, so it's not debug draw that anymore. Okay. So, profiler. Problem with the profiler right now. So when we set to profile individual shaders, well, the parallel sort, the FFX sort, AMD's sort, which are ported over to the code base. Look at all those. There's more than that as well. They're quite small. It'd be good to maybe have a tree of those or something so we can at least tab them in and see a total time, but also be able to collapse it maybe. Yeah, I don't know what is best. So I think ultimately we do have to build a way to build a tree of these, start and stop different sections that can be grouped together. Tile bin took a millisecond. Huh? Took a millisecond to bin two ellipsoids. Is it really that slow? The past one wasn't that slow. Hmm. We've disabled all the debug stuff, right? All the printing, just as this. It's all these big for loops and adding and writing these maybe. Close the dam. Right, maybe it was filling in a lot of tiles. And that's just expensive. Right, it's not that bad there. Right, but I guess what was happening, if I can resume that. No, apparently not. What was probably happening is when it was off the screen. Yeah, I guess the big problem is when they fill a whole bunch of tiles. I don't know. Anyway, we'll look at that some other time. Yeah, so we need a way to group these up. Probably minimize them as well. Ones we don't want to see. It's real as fuck. Hey, nameless. I swear someone's come in here before called nameless, but you're probably a different person. Yeah, I get that. I get that a few times. It's been a while since I had that one though. Yeah. That's cool. Yeah, it looks it's just a cube map, and then we're using PBR for rendering those ellipsoids. So yeah, the scene is a picture from real life. It's someone else took it. I didn't take it. It's somewhere in Japan, I think. Um, and then yeah, the ellipsoids are just PBR rendering, so they're physically based rendered. So it is kind of modeled after the real world, um, light and the way light works. But yeah, it's physically based, meaning it's not physically 100%. Um, but yeah, that's typically what games do if they go for like a realistic look or sometimes even a cartoony look. Um, these days, is they use PBR to make the lighting, because good lighting makes your game look more professional. Um, yeah, typically people just integrate PBR into their workflow for that. Yeah, I think what we'll need to do is add an API that allows you to push and pop the profiler stuff so you can put in sections. Um, but yeah, I don't think we have time to do that today. It's definitely doable. But yeah, I think we're gonna need it very soon. I might do that off stream, or we may do it if we have spare time at the end of another stream. We'll quickly add that in because yeah, this is just ridiculous. Yeah, we've got to keep an eye on this tile bin ellipsoids as well. Maybe there's a different approach we could take because this 2D loop is probably expensive. Um, yeah, it would be. It's not really that great, is it? Because if you've got two ellipsoids which loop over a different amount of tiles, you'll get a lot of inactive lanes as well. Yeah, I wonder if there's a better way we can organize it. Like when we're changing out for the models probably want to process. I wonder if you could take the ellipsoids, know which ones you want to bin. So check if they are not occluded and inside the screen. Put them out to another buffer, and then you run another shader, which actually does the tile binning. Or maybe you do it all in one. Yeah, maybe. Like actually duplicating it into the array, you want to make a shader which just emits the ellipsoids very fast. Yeah, you could probably do a thread group per, sorry, a wave 32 per ellipsoid. Yeah, that'll do it. And you'll be able to do like 32 at a time. It's just you'll have to get the you'd have to get the tile indices right because they, you'll get some sort of section of the screen where you're trying to fit them into these tiles. Maybe we just make the tiles bigger and this problem gets less as well. There'll be less tiles to fit in. 4 times less tiles. Yeah. something to look into. What did I do in the past? Double check that. Tile bin. Or bin ellipsoids. What do we do there? Right, binned entries count. This is it. Right. So we did do this silly loop. Yeah, one thread for each sphere. We did the silly loop and it just worked out. Probably because the spheres were very small. Now this is where the ellipsoids can actually be bigger. But yeah. So interesting. Yeah, I don't think they're going to be that big. But yeah, we've got to solve the problem where if you have bigger ellipsoids, how do you quickly duplicate their data inside the... Hmm. Yeah, you could probably pack them in fast. It's just setting up that tile index fast. Interesting. Why not using Vim? Yeah. My Linux machine. Well, I went from Vim to Helix, and then I installed a new AMD GPU, and then it fried my Majora install. So I've now got to reinstall Manjaro again. Well, I'm gonna install Arch actually, probably. I'll be getting a new drive tomorrow, and I can take the old one out and keep it as a backup. I'll take the Windows machine out, where Windows hard drive out. They're both separate, and I'll put the new Arch one in, install it all from scratch, and then hopefully get it up and running. Yeah, I might try that tomorrow, um, and a bit of Saturday, and hopefully it's ready by Sunday. Hey, Silo, it's been a while. The advantage of PBR is better definition handling of material types. Yes. Yep. There's many types of materials you can do as well. Like we only did the basic like metallic and roughness or metalness and roughness. But yeah, you can. And we only did a BRDF, but there's other ones you can do as well. Um, there's lots of other properties you can get. I've been looking for some good streams related to game dev. What do you recommend me read before getting into game dev? Board of web dev, want to switch the thematics? Um, yeah, I think I do, Sherlock or Silo. I think so. What do I suggest? Well, I don't really know of any books because I don't read books. I don't think you asked for books actually. You just said read. What I recommend instead you do is probably just get in there and start doing stuff. And read as you need to learn. I recommend you get started with Raylib. Um, you can download it, and you can make 2D games in it. Um, if you are new to sort of the lower level side of things or new to programming in general, Raylib is easy to use after you get it set up, and compiling with it as a library. There's plenty of examples where you could, you know, here's a 2D camera. All the code is in here to do that. You literally, the whole program, you can copy paste it in, have a bit of a play around with it. You know, and then you can do your own, you can even play the example in here. But yeah, I recommend making something 2D using Raylib. You can do 3D, but 2D is just a lot less maths. If you haven't got that much of a maths background, you're probably better off sticking with 2D for a while and really learning about making games, 2D games, before you try and make a 3D game. 3D game is a lot more maths and is like the amount it takes to learn to make 2D, a good 2D game. You basically have got to that struggle of doing that. You've got to do that all again, 3D. So yeah, I recommend just getting going. I guess you want to make games. So if you want to make games, you can use Raylib to get up and going quite easily and make a few little clones like Asteroids or Snake, or pick a really old game because they were simple and just get programming that old game, but with your own twist, right? Like Brick Breaker or something. And then after you've done a few of those, you can try and move to something. After Raylib, I think the next level up is SDL. SDL3, you should get that one. You'll be able to integrate this into your project and you'll have all the platform layer done, so you'll be able to write your own engine. But you won't have to write the platform layer. So work on Windows, Linux, Mac, and other platforms as well. And they have their own GPU backend now. So you can target this GPU backend which SDL provides, and it'll be cross-platform and work on Vulkan, Metal, and I think DirectX 12. And it's actually quite a good GPU backend. I would recommend it for people who haven't bothered to try and learn Vulkan, because Vulkan is very complicated and it's a lot to wrap your head around, and it does get in the way of just making a game. But yeah, those are the two suggestions I would say. Just get going and use those two use one of those two libraries. But yeah. Right. So that was a good, successful day. I'll put the code up on the GitLab for those who are supporting the channel. Thank you so much, guys. Appreciate you lot so much. Sundays when we'll next be on, about 4 hours ago, starting on Sunday. We're working on instances of models. So we have some models already. They're very basic models. We've got like a couple of shapes in there, but there's models at least. We're going to get those working by keeping track of models and then making instances of models, and those instances will be the ellipsoids from those instances will be taken and then binned using this tile binning code, and then they'll be rendered using the rendering code that we've already got. And then we should have at least where we were before, but with the new renderer, and then we can optimize it, occlusion buffer, and fix this tile binning code when you have stuff which fills a very big portion of the screen or multiple tiles. How do we bin quicker? Basically, how do we figure that one out? But yeah, right. What do I do for my day job? Graphics programmer. Work for PlayStation Studio. Yeah, I'm on the graphics engine team. Is this GPU rendering? What part is tile based? Yeah, so we basically took these ellipsoids because we're not rendering triangles. I wanted to accelerate the rendering. So rather than per pixel going over every single ellipsoid that could possibly be rendered, instead we go over a small array. And there's an array per screen tile. So how it makes it tile based is it kind of is inspired by how tile based GPUs work, where it basically bins the ellipsoids into screen tiles, where a tile based GPU will bin triangles into screen tiles. So ours are 16 by 16 pixels, but yeah, they definitely vary depending on the platform. But yeah, right now mine is 16 by 16 pixels, but I'm thinking about increasing it for 4K resolution or a 4 above 1080p because there's just quite a lot of tiles otherwise, and it does impact performance. Well, it's a trade-off. We've got to have a play. But yeah. Mm. But yeah, there's a Discord link if you want to come and hang out in the meantime and chat. There we go. Right, let's find someone to raid. Teacup raid maybe. Ah, there's 3 people on. Oh, Artie's just came on. Let's give Artie a raid. All right. Have a good start to your weekend. I'll hopefully see you all on Sunday.